So one of our most common sequences is called an arithmetic sequence. And so the first thing you need to do is think linear. So when you have an arithmetic sequence, it has linear tendencies. So when you look at a table of a linear function, you've got numbers like 1, 3, 5, 7. And then as you look at the loop-d's, they're going to be plus 2, plus 2, plus 2. The same thing goes on for an arithmetic sequence. Only instead of being in a table format, it's just a sequence. So you've got 1, 3, 5, 7, and so on. And then if you look at this, you're going to be adding 2 every time. Now, this adding 2 is called your common difference. It's what we call the loop-d. So instead of the loop-d on the table, it's our common difference. And you have to come up with a rule or the equation for the arithmetic sequence. Now, when I come up with a rule for a linear, we use y equals mx plus b, and that's what we're comfortable with. M is our loop-d number, and b is our y-intercept. But if you remember in our last video, y-intercept happens when x equals 0, and don't forget that really x equals 1 when we're working on these arithmetic things. So we have a bit of an issue here with that b value. So here's what we do. The formula is actually a little bit different than y equals mx plus b. The formula is, or the general rule is a sub n, remember we use that instead of y, equals n minus 1, remember n is used instead of x, times d, that's our loop-d number, so that makes sense. So normally this is an x, times d, plus, instead of the y-intercept, we're going to go a sub 1. So we want to be able to use the first term in our sequence as our y-intercept spot, as our b spot. But in order to do that, we have to now take this, and instead of it just being an n like we want it to be, we're going to go n minus 1. So it takes care of that 0, x being 0 part, and allows us to put in our y-intercept here. So for this problem up here, the general formula would be a sub n equals n minus 1 times d, which is 2, because we're adding 2 every time, plus the first term, 1. Now if we were to simplify this all out, I could take that 2 and multiply it through, so 2n minus 2 plus 1 equals 2n minus 1. And that goes back to, if we went back up to the top, if I brought that loop-d back 1, so if we went back with the loop-d, that would bring us to minus 1, which is actually the y-intercept. So it works out the same, it's just that we don't have to go back anywhere, we can just use this formula, or this formula I suppose, to get us that equation. So let's look at an example here. So let's write a rule for the nth term if, let's give us d equals 4 and a sub 14 equals 46. So the general equation, you're going to want to write that down first. A sub n equals n minus 1 times d plus a sub 1. Now a sub n, that's this a sub 14 that they gave us. That's what we're looking at right here. So we've got a sub 14 equals, now we know that n is 14 because of that 14 there, so 14 minus 1 times d, which is 4, plus a sub 1. Our goal here, by the way, is to figure out what is d and what is a. So this 14 is temporary, but I have too many variables as it is. I have a sub 14 and I have a sub 1. Lucky for us though, a sub 14 is 46, so I'm going to plug that in for a sub 14. So I go back and I've got 46 equals 14 minus 1 is 13 times 4 plus a sub 1. So then just a simple math here equals 52 plus a sub 1. Subtract 52 from both sides. Oh, that didn't work very well. And this would be then 46 minus 52, negative 6 equals a sub 1. So now my formula, I go back to here and I want to rewrite that. So I've got a sub n equals n minus 1, remember we want to keep the n there, times d, which we know is 4, and now plus a sub 1, we know that's minus 6. So there would be our rule, unless you were to simplify it down further. And so then you have a sub 1 equals 4n minus 4 minus 6. A sub n equals 4n minus 10. So you could use either one as your rule. Now let's do another rule. Okay, let's look at if a sub, let's go into page. Let's do a rule if a sub 7 equals 34 and a sub 18 equals 122. Now this is going to give us an interesting one, because what you'll find out is we actually have two variables. So remember, we have a sub n equals n minus 1 times d plus a sub 1. So if I focus on this first one here, I've got a sub 7 equals 7 minus 1 times d. We don't know d, and we don't know a sub 1. And I need to replace the a sub 7 with what that equals, which is 34. Okay, so this really is 34 equals 6d plus a sub 1. I've got too many variables, but that's okay, because I can also go over here and work with this one. So I have a sub 18 equals 18 minus 1 times d plus a sub 1. And then remember, we know a sub 18 is 122. So now we have 122 equals 17d plus a sub 1. So I've got two equations with two variables. And if you haven't thought of it yet, we're going to be using elimination or substitution to solve for this. So what we're going to do is I'm going to make one of them negative. So why don't I take this one and make it negative? So I've got negative 34 equals negative 6d minus a sub 1. And then 122 is positive, equals 17d plus a sub 1. And you'll notice the a sub 1's cancel out. And then I get 88 equals 11d. Divide by 11, 8 equals d. And then we can go in and solve, and if 8 equals d, we can plug that in for one of the d's, and we get that a sub 1 equals negative 14. So my equation then would be a sub n equals n minus 1 times 8 minus 14. And of course you could simplify that also. So, oh, no, what do I want to do? So now if we're talking about a series, that means we want to add them all up. And there's luckily a formula for that. So if we want to add up, so we'll use S for the sum of the first n terms equals n times a sub 1 plus a sub n all over 2. So it looks like we're taking the average of the first term and the last term. So we'll take the first term and the last term, add them up, divide by 2, and then take that times how many terms we're talking about. So in this example we have 10 terms. It starts with 20 and then adds 18 and 16. We'll notice that d is going to be a minus 2 because we keep subtracting 2. And in order to do this, I'm going to take s sub 10 equals 10 times a sub 1 is 20 plus I don't know a sub 10 yet, so I need to find that divided by 2. So to find a sub 10, we're going to use our formula. A sub 10 equals 10 minus 1 times d, which is negative 2, plus 20, which is our first term. So that just comes from the general rule of an arithmetic sequence. Okay, do our math. So we get 9 times negative 2 plus 20, which is negative 18 plus 20 equals 2. So then I can go up to a sub 10 here, and I can put just a 2 in there. And then I get 10 times 22 over 2, which would be 10 times 11, which would be 110. So the sum is 110 if I was to add all those up.